Hello everyone, in this tutorial I'll solve the exercises of lesson 2-4. Question 1 to 6. Use the given graph to find the limit of for the given point from left and right and discuss the continuity. Number 1, we have this graph. We want to find the limit when c equals 3 from left and from right. When x approach to 3 from right, the function is 1. Therefore, limit x approach to 3 from right for f of x equal 1. From left, also the value of f of x is 1. Therefore, the limit in general when x approach to 3 is 1. And since the value of the function when x equals 3 is 1, then this function is continuous when x approach to 3. Number 2, c equals -2. The limit of this function when x approach to 2 from right is -2. From left also is -2. Therefore, the value of the function is -2 also. Therefore, this function is continuous when x approach to -2. Number 3, when x approach to 3, discuss the limit and continuity of this function when c equals 3. When x approach to 3 from right, the function goes to 0. Limit x approach to 3 from right for f of x equals 0. Also, from left of 3, the limit is 0. But f of 3 is 1, as you see here. Therefore, this function has a limit when x approach to 3, but it is not continuous. Number 4, discuss the limit and continuity when c equals -2. When x approach to -2 from right, the function goes to 2. When x approach to -2 from left, the function also goes to 2, but the value of the function when x equals -2 is 3. Therefore, this function is also not continuous when x approach to -2. Number 5, discuss the limit and continuity when c equals 4. When x approach to 4 from right, the function is 2. Limit x approach to 4 from right is 2. Limit when x approach to 4 from left, the function is -2. This function has no limit when x approach to 4, and f of 4 is 2. This function is not continuous and has no limit when x approach to 4. Number 6, discuss the continuity when c equals -1. When x approach to -1 from right, the function is 0. From left, the function is 2. This function has no limit when x approach to -1. Therefore, this function is not continuous. Question number 7 to 10, discuss the continuity. F of x equals 1 over x power 2 minus 4. As you see in this graph, this function has discontinuous point at 2 and -2. And if we want to find the limit of this function when x approach to 2, then the value is undefined. 1 over 2 power 2 minus 4, 1 over 0 is undefined. Also, when x approaches negative 2, the function is undefined. Therefore, the function is not continuous when x equal 2 and x equal negative 2. Also, the function has non-removable discontinuity when x approach to these points. Number 8, f of x equal x power 2 minus 1 over x plus 1. As you see, this function is not continuous when x equal negative 1, because negative 1 make the denominator 0. But the limit of this function exists when x approach to negative 1. Therefore, this function has a removable discontinuity when x approach to negative 1, since the limit exists. Number 9, the function is 1/2 greatest integer number of x plus x. This function, we solved it before. This function has a discontinuous point when x is integer, not integer number. As you see, when x at the integer number, the function is discontinuous, but at non-integer number, the function is continuous. And the point of discontinuity is non-removable. Number 10, piecewise function. It is not continuous, as you see, when x equal 1, since the limit of the function when x equal 1 is 1, but the value of the function is 2. As you see here, f of 1 from left is 1, from right 2 times 1, 1 minus 1 also is 1, the limit exists and equal to 1, but the value of the function is not equal to the limit. Therefore, this function has non-removable discontinuity. Or we can redefine it by setting when x equal 1, the value of the function is 1. Exercises 11 to 16, find the point of discontinuity and specify if the point of discontinuity is removable. This function has no point of discontinuity because it is quadratic function, it is polynomial of degree 2. Therefore, it is continuous everywhere. Number 12, f of x equal 1 over x power 2 plus 1. Also, this function has no point of discontinuity since its domain is R, because x power 2 plus 1 not equal to 0. There is no value, there is no real number make it 0, since x power 2 equal negative 1 and x equal positive negative square root negative 1, not a real number. Therefore, this function has no point of discontinuity. Number 13, f of x equal x over x power 2 minus x. Set x power 2 minus x equals 0 and solve it to find the values of x. X factorized by x, x minus 1, then x equals 0 and x equal 1 are point of discontinuity of this function. But the point x equals 0 is removable. The function has removable discontinuity when x equals 0 because if we find the limit when x approach to 0 for this function, then the limit exists factorized by x minus 1, then the value is negative 1. But when x approach to 1, the function has non-removable. There he removable. Number 14, x over x minus 1. This function has set x minus 1 equals 0. Then this function has a point of discontinuity when x equals 1, and this point is not removable because the limit when x approach to 1 for this function is not exist. Number 15, this function has point of discontinuity when x equals 3, and this point is not removable point because the limit when x approach to 3 for this function not exist. It is negative 1 when x approach to 3 from left and 1 when x approach to 3 from right. Number 16, this function, let us check the continuity of this function when x equal 1, f of 1 equal 1. This is the function, this segment. Limit x approach to 1 from left, I substitute here minus 2x plus 3 equal to negative 2 times 1 plus 3 equal to 1. And limit when x approach to 1 from right, substitute here, also is 1. Therefore, this function is continuous everywhere, has no point of discontinuity. Number 17, find the value of a if this function has no point of discontinuity. Since the function has no point of discontinuity, the limit when x approach to 2 from left equal to the limit when x approach to 2 from right. From left, I substitute in this segment x power 3, then 2 power 3 equal 8, and limit when x approach to 2 from right, substitute in this segment the function, the value of the limit will be 4a, 2 square times a, 4a. Since the limit from left equal to the limit from right, then 4a equal 8, therefore a equal 8 over 4 equal 2. Number 18, find the value of a and b such that this function has no point of discontinuity. Find the limit when x approach to negative 1 from left. From left, it is 2. And limit when x approach to negative 1 from right. From right, when x greater than negative 1, it is ax plus b equal to a times negative 1, negative a plus b. Since the limit from left equal to the limit from right, therefore I have equation negative a plus b equal 2. Now, the limit when x approach to 3 from left, when x less than or equal to 3, the segment is ax plus b equal to 3a plus b. And the limit when x approach to 3 from right is -2, and the limit from left equal to the limit from right. Therefore, we have two equations in two unknown constants. Solve it to find the values of a and b. -a plus b equal to 3a plus b equal -2. By subtraction, b with b, -a, -3a, -4a equal 2 plus 2, 4. Therefore, a equal -1. 4 over -4, -1. Substitute in this equation or in this equation to find the value of v. -1 plus b equal 2, 1 plus b equal 2, b equal 2 minus 1, 1. Question number 19. Give an example for these three cases. Function with non-removable discontinuity at x equal 2. Function with non-removable discontinuity at x equal 2, 1 over x minus 2. This function has discontinuous point when x equal 2, and this discontinuity is not removable since the limit is not exist. If the function has a limit when an x approach to a discontinuous point, then this point of discontinuity is removable. If the function has no limit when x approach to point of discontinuity, then this point is non-removable. Function with removable discontinuity at x equal -2. F of x equal to x plus 2. This function has a discontinuous point when x equal -2, and set the numerator x power 2 minus 4. The point -2 is discontinuous point, but this discontinuous point is removable since the limit when x approach to -2. Analyze the numerator. Reduce x plus 2 with x of 2. Substitute every x with -2. The limit exists, therefore the discontinuity is removable. Function satisfy a and b. It means function with 2 points of discontinuity, 2 and -2, and -2 is removable discontinuity. Set f of x equal to x power 2 minus 4 over x power 3 minus 8. This function has two discontinuous points, x equal 2 and x equal -2. And this function has a removable discontinuity, when x equal 2. Let us check the limit when x approach to 2. Then analyze difference of 2 cube, x minus 2, x power 2 plus 2x plus 4 over x minus 2, x plus 2. Reduce x minus 2 with x minus 2. This function has removable discontinuity at 2 and non-removable discontinuity at -2. We want the reverse, therefore I'll take x power 3 plus 8. It will be x plus 2 minus 2x plus 4. Reduce x plus 2 with x plus 2, then this function has a removable discontinuity at -2 and non-removable discontinuity at 2. Question, the last question in this set. S of x equal -1, 0, 1 when x less than 0, x equals 0, x greater than 0 respectively. Sketch the graph of this function. The graph is when x less than 0, this is 0, x less than 0, the function is -1. This is -1. This is the first segment. X equals 0, f of x equals 0 when x equals 0, s of x equals 1 when x greater than 1. When x greater than 1, the function is 1. The limit for f of x when x approaches to 0 from left, as you see, the function is -1 graphically. Limit s of x when x approaches to 0 from right, the function is 1. Therefore, the limit when x approaches to 0 for s of x is not exist. Mathematically, limit x approach to 0 from left, it is -1. Limit x approach to 0 from right when x greater than 1 is 1. And therefore, since the limit from left not equal to the limit from right, the limit not exist. See you next lesson.